Buenos días de nuevo a todas y a todos, aquellos que estáis en Latinoamérica, y buenas tardes a los correspondientes de Europa. Como sabéis, hoy es el último día de este evento temático virtual denominado Exploración y Tecnologías Innovadoras, Políticas y Prácticas, que está englobado dentro del proyecto de Horizon Fortaleciendo la Cooperación Europa-América Latina en la Transición Energética, con el acrónimo EULAC Energytran. Quería aprovechar para hacer un pequeño recordatorio antes de ir al siguiente panel. Y es que todos podéis activar los subtítulos para que todo lo que estemos hablando aparezca en la lengua que vosotros queráis, ¿vale? Especialmente porque, como comentábamos en la sesión de ayer, los idiomas vehiculares del proyecto son el español y el portugués, y por tanto son los idiomas que se van a desarrollar, pero el panel número 4 va a ser en inglés, ¿vale? Entonces, recordad que podéis activar los subtítulos. También quería hacer un pequeño recordatorio de cuál va a ser el esquema que vamos a seguir hoy, que básicamente va a ser el debate de dos paneles. Vamos a hacer un pequeño descanso y vamos a enfrentar un último bloque, que es lo que hemos denominado debate de proyecto y la síntesis y principales conclusiones de los debates. Y daremos más detalle cuando lleguemos a este bloque. Bien, este panel va a ser en inglés, so from now on I will speak in English. The next discussion panel will be conducted in English. This panel is titled Technologies for Energy Sustainability. It will be moderated by Álvaro Videla. He's affiliated with PUC and the Energy Center UC, both from Chile. PUC means Pontificia Universidad Católica de Chile. He's associate professor, He's associate professor, UC Department of Mining Engineering, and director of the UC Energy Center. His academic background includes a Master of Science and a PhD from the University of Utah. And regarding his research experience, his primary areas of involvement are energy consumption in mining processes, optimization of mining extraction processes, analysis of technologies and opportunities in mining, design of solutions for the optimization of extraction processes, critical materials for energy transition, energy storage with molten salts, lithium batteries, and process optimization, and energy efficiency. And Álvaro, I would like to make the comment. Please indicate to the audience the designated person to whom they should send their questions to the chat. So I guess in that case it is Arturo, but let everybody know. And then Álvaro, the floor is yours. And you can share your screen.
Okay, thank you. Thank you very much for the introduction. Well, thank you everybody that has been on the organization of this webinar. And I'd like to introduce the person that will join me on this conversation. First of all, it would be with us Robert Solak from the Sustainable Synthesis Product Fraunhofer Institute for Solar Energy Systems, Germany. Robert, thank you for joining us. Robert is the chief of the Department of Synthesis of Sustainable Fuels, basically focused on hydrogen. Since 2015, has been related to the analysis of thermochemical processing and development of process for the hydrogen industry. So thanks again for joining us. I hope we could have a fantastic interaction today. Robert, are you there?
I'm here, yeah. Thank you, Alvaro, for the invitation, and thank you for the introduction.
Fantastic, Robert. Also, I'd like to present to Dr. Juan Carlos Fierro. He is chemical engineer at the Technological National of Mexico in Celaya. His group investigates the synthesis of support metal catalysis and their characterization and their reaction, conduction by spectroscopic techniques. He obtained his bachelor's degree in chemical engineering from the University of Autonomous San Luis Potosí and his PhD from the University of California, Davis. Currently, Professor Fierro served as Vice President of the Mexican Academy of Catalysis. He's also the leader of the thematic network for the development of the value chain of strategic mineral in Mexico. Thanks, Juan Carlos, for joining us.
Good morning or good afternoon, and thank you for the invitation. It's a pleasure to be here.
And finally, I would like to introduce to my dear colleague, Felipe Huerta. He's a PhD from Imperial College London, a master from University PUC. He's currently assistant professor in the Department of Chemical Engineering and Bioprocesses at PUC. He teaches transport phenomena and unit operations. Since 2019, he has been the receiver of the John Archer Award for Research Excellence in Geoscience and Petroleum Engineering. Also, his current research areas are modeling and simulation of transport phenomena, cryogenic fluids, process intensification, and energy storage. Thank you, Felipe, for joining us today.
Thank you, Alvaro, for the introduction. I'm looking forward to participating into this panel.
So we're going to start, as the program said, we're going to start a brief discussion about the green hydrogen challenges and opportunity, innovation, and cost.
Alvaro, sorry
Yes?
to interrupt you, but you are not sharing your screen, and I guess you want to share your screen, right?
I thought the presentation is in your hand. Could you present it?
No.
We don't need the screen anyway, because the questions are not in the presentation.
It's okay. I will share my screen because I have your presentation. Okay.
Yes, that's fine.
Yeah. Now everybody can see the screen.
Yeah. So I'd like to start this discussion and conversation regarding the hydrogen industry and the current situation of this industry in general. So if it's possible for Robert to give us a brief introduction, Robert, about your thoughts about what are the most recent innovations in the green hydrogen production technology and how they are changing the energy landscape in Europe and as well in Latin America. Robert.
So yeah, I just have to unmute it myself. I can give you some thoughts about myself. I mean, green hydrogen will be produced from renewable energy via electrolysis. The current state of the art is alkaline electrolysis and polymer electrolyte membrane electrolysis. This is state of the art. There are currently, we will see the assembly of gigawatt factories for both technologies, and they are waiting for the market. What we know is, I mean, hydrogen will empower the energy transition, and hydrogen, of course, will be a key factor in the achievement of the climate neutrality. We will need globally around 600 million tons of hydrogen to achieve climate neutrality in 2050. However, hydrogen will be a huge global market, and it can be used for in all sectors, in the industry sector, in the transport sectors, for the building and the power production.
But let's say, Robert, is this in place already, or it is in development, right? I mean, if you could give us brief numbers about where we are with this production capacity in the world.
Yeah, I mean, there will be there's a gap, to be honest, of projects, globally announced projects, and the number of projects that reached FID. Just to give you some thoughts. So we globally around 1,400 projects are announced globally. And the number of projects that reached FID are currently 100. And that's the gap that we have. So we have our targets. We have our targets to in Europe and also in other countries. But yeah, we have to hurry up.
Thank you, Felipe. Could you give us some impression about what's happening with this development in Latin America, in particular?
Yeah. Well, I wanted to answer something different to complement Robert, so I will answer first your question. Regarding developments in Latin America, there are a number of them in Mexico. I think that is like pushing the bar quite quickly. Brazil and of course in Chile with quite a lot of support from the government in terms of some sort of partial funding or accelerators, mainly on electrolyzers, as Robert said, as the hydrogen production, when the hydrogen is green, can come mainly from two routes: the water splitting route, that you have their electrolysis, thermolysis, or photoelectrolysis, and the biomass route. In the biomass route, you have got biomass gasification and thermochemical cycles, but they have at a lower stage of technology readiness level. So I think in the case of Latin America, I think it will change quite a lot in the next decade, depending on how these new technologies achieve maturity, because eventually I think that although biomass availability, there is no a big supply chain, it may be something important for Brazil, or even for us in the south of Chile. While on the other hand, on the electrolyzers, from one hand, we have all the advantages that, for example, Chile has in terms of high solar irradiation and wind power. However, still the capital expenditure cost of the electrolyzers is very high, and the cost needs to decrease quite a lot. It is expected to decrease, and it is decreasing quickly, but it's still, we are, as Robert said, a bit far from making this commercially available. And I wanted just to mention one thing, complementing Robert regarding proton exchange membranes and alkaline. So with an emerging technology that are solid oxide electrolyzers that can achieve higher efficiencies, around 84%, versus the range between 60 and 70 for that alkaline and proton exchange membrane can have. But they require high temperatures, and they are in a lower technology readiness level, but it's not super low. It's between 7 and 8. So we hope in the next years to make this commercially available. I mean, I hope, because there are some opportunities for industries like the mining industry in Chile, as this technology requires heat input, not only electricity to produce hydrogen. So to make it competitive, it will require a level of process integration.
Thank you.
If you have heat available, so that would be a really good choice. If not, the alkaline and PEM electrolyzer will be the better choice. But of course, if you have excess of heat, and you can use it, yeah, and fully agree, the technology readiness level is lower than for the other two electrolyzer systems.
Thank you, Robert. Well, but the development of the green hydrogen industry need renewable energy. So I guess countries that are plenty of renewable energy available are best fit to develop this industry. So in that regard, South America and Latin America has different renewable energy sources that could put it in a good position to lead this industry. But the demand is in Europe, Robert. So what could be done so the hydrogen could be carried to these long distances in an effective way? So this really could become cost effective. What are your thoughts about it?
Yeah, I mean, we will see and some diverse hydrogen production places. We will produce hydrogen in Europe itself, transport it via pipeline to Germany, or to distribute it over those pipelines in Europe. We will definitely will have some hydrogen from the MENA region. There are also some plannings regarding pipelines from the MENA region to Europe, but yeah, we also need imports from other countries. That means from countries with also really good conditions for renewables and for the hydrogen production. That means the transport, the hydrogen will be transferred to other molecules like ammonia, for instance. We will definitely see ammonia as a hydrogen carrier for long distance. Ammonia today is an important bulk chemical with a global production capacity of around 150 million tons per year. It is easy to liquefy and easy to store. And ammonia is also a high specific energy density. And of course, you can produce ammonia from green hydrogen and nitrogen from the air. But to transport ammonia via ships, you will need really lots more of shipping capacity. So we also seeing another molecule which is called dimethyl ether, DME, which is also a great hydrogen vector for long distances. The advantage of dimethyl ether is, from our point of view, it is non-toxic and it has no environmental impact. You can store this really easily, like a liquefied gas under slight pressure, roughly 10 bars. You can use LPG as a substitute for LPG. You can blend 20% of DME to LPG without any changing in the end user side. DME is also an intermediate for sustainable aviation fuel. And also as a hydrogen carrier, dimethyl ether has a really high hydrogen capacity, higher than ammonia. And we published recently a paper comparing ammonia with dimethyl ether, and we showed that we are considering a closed carbon dioxide cycle with DME synthesis, including transport to Germany. So the DME has some cost advantages. So we ammonia and dimethyl ether is here great chance
So
to.
So in your view, ammonia and dimethyl ether are the best fitted carriers
from my point of view,
transport
right?
hydrogen from Latin American countries to Europe. Very interesting. So one would be a nitrogen-based molecule, the other would be a carbon-based molecule. We will see what happens, which one becomes more competitive. Perhaps the next question would be, what are the challenges, Robert, still to be solved in these both alternatives, right? Because both of them need to be cracked at the end of the road to produce hydrogen. How could be done in a way that is completely sustainable? How you control the cycle of CO2 in the case of dimethyl ether, and how you avoid the use of Haber-Bosch in the case of ammonia.
Yeah, of course. There are some challenges, but just go to ammonia. I mean, as I mentioned it before, ammonia is a bulk chemical already. I mean, it's shipped in million tons per year all over the world. We don't see much accidents because the people know what to do. So you need good educated people handling with this ammonia. But the main technology challenges I see for the entire value chain is first of all, you need a cost reduction. Really covering the entire value chain, you need a cost reduction of the power generation, as well as for the electrolyzer itself. And even if you look into the electrolysis, the scale up is just at the beginning. So we will expecting a cost reduction over the time. There are also some technical improvements necessary regarding higher component lifetimes, and also a larger operation window. For instance, if you're looking into the ammonia value chain, the operation window of the ammonia synthesis is not that high. That requires really cost-intensive hydrogen intermediate storage. And if you work on synthesis, which a wider operation window, you can also reducing the costs. And as you mentioned it, closed carbon loop and direct air capturing, especially the direct air capturing is up to now a bottleneck for the production of carbon-based molecules like methanol or sustainable aviation fuel.
Okay, thank you for sharing that with us, Robert. And Felipe, in your opinion, what would be the main challenges on hydrogen carriers to make such a long distance, or how do you see the technology development in storage and transport going on?
Yeah, so making my contribution from the academia to speak about technologies that are still maybe in a lower technology readiness level, but they are growing. So one of them are liquid organic hydrogen carriers, such as methyl cyclohexane and toluene. So although this pair has a lower gravimetric density of hydrogen per mass of carrier transported, again, it may have some interesting applications in countries in South America if there is some heat that can be used to decrease the cost of that part of the supply chain. Because when you want to, you start with this carrier, and basically how they work is that methyl cyclohexane has hydrogen, then you dehydrogenate it, which is an endothermic process and it requires heat. And then you create toluene that you need to send it back for the hydrogenation, where you can store the hydrogen chemically in the molecule. And that's an exothermic process. So it's quite, in terms of cost, if you can do anything to use that heat at any of the 2 points, it can become similarly competitive. It has the advantage, it's not the most safe molecule, but it's definitely less toxic and dangerous than ammonia. But it may be something also of interest because, and one of the challenges are very similar to the ones that Robert mentioned, which is mainly the cost. So you need to build like a whole plant, expensive catalyst, both for the hydrogenation and dehydrogenation. But that with more research and development may get better. On the other side, we have liquid hydrogen. Yeah, so one of the problems of the chemical carriers is that in the receiving terminal, you need to have the capacity to dehydrogenate the molecule, to recover the hydrogen back from the ammonia, the methyl ether, and liquid organic hydrogen carriers. With liquid hydrogen, you have the advantage that the only thing you need to do is to evaporate it. However, it's a cryogenic liquid at a very low boiling temperature, minus 253 degrees, roughly 21 Kelvin. So producing it is really expensive, even if you already have the green hydrogen. That is a bit expensive. It's quite expensive to produce nowadays. And then bringing it to liquid, you require a complex and expensive refrigeration cycle and liquefaction cycle. But what you get is that it's much easier for the buyer, if it can afford the money, to recover the hydrogen, because you just basically need to heat it and evaporate. So I don't think there will be like a single carrier technology, I think all of them will have a different participation, and which one will be the most cost effective will really depend on the situation of the country and in terms of how long you want to carry the hydrogen. For very long distance hydrogen, I also like with Robert, probably what he suggested, ammonia and dimethyl ether, thinking of shipping from here to Germany. It sounds like a very most promising option in terms of cost and technology maturity, but maybe from shorter deliveries or storage in general, one could think on other carriers or even a combination of that.
Well, I agree with you both, because we are in a sort of early stage of development of this technology that probably we will see developments in all these different type of carriers, right? Until we finally have enough information to be certain about which one has more advantage. But at the end of the road, maybe it will happen that it will be a case-by-case analysis. And sometimes one would be best fit for some areas than others. So in this regard, I would say, in your opinion, Robert, and then later, Felipe, I will ask you the same question. How can Europe and Latin America and the Caribbean collaborate to do this technology more effective, to face the challenges that we are sharing here? Because there are too many questions, too many unknowns yet. Robert.
Yeah, how to you mean yeah, what
are the paths to collaboration to answer all these unknowns that are, they are delaying the development of this industry?
Yeah, of course. I mean, we have to work on both ends of the production side as well as on the off-taker side. So we need definitely work together on this area to look specifically on the region, on the area itself. What is really the potential? What is the demand in Europe, for instance, or for other customers? But yeah, this is definitely the main point will be to work globally together on that topic.
Yeah, I think it's my turn now. Yeah, well, I think the main big difference of what advantage Europe has compared to Latin America is the technological and engineering capacity, because many companies, such as Fraunhofer, Linde, they have been working with gases and these chemicals for a long time. So that would be an instance of collaboration that whenever you need to come and build a new plant, because there we'll need to build quite a number of new plants and quite a number of storage tanks for most of these new technologies. So that would be will require some level of technology transfer. While what South America has to provide, I think it has potential to of human capital, let's say people that are that will in one part you have lots of like talented engineers that maybe will need to repurpose their knowledge, and there could be a potential collaboration, because also in the case of Germany, for example, they still, I mean, they have quite a lot of technology, but again, they are always looking for human capital around the world, because maybe have like engineering challenges that are so many and so big. So I think it needs to be connected with the human capital side. And one challenge I see for South America, in the case of particular Chile, is that building these plants may take a lot of time, because you need to get a lot of permits in terms of the regulatory side. And also the normative for these new technologies is not fully developed, so that may delay the startup and development of these new processing plants that you will need to do.
Thank you, Felipe. Thank you, Robert. Just stay there because we are on a switch of topic now. And then at the end of the conversation with Professor Juan Carlos, we're gonna wrap it up, all the discussion. Before switching to the next topic, Juan Carlos, I would like to give you the possibility of comment on any of the ideas that you have here, given that you also have some expertise on catalysis. So yes. The same questions. I mean, what do you see? What possibilities you see? What the challenges that you observe? How we could collaborate with Europe on this regard? Please.
Yeah, well, thank you. I think from the perspective in catalysis, there are enormous challenges to make sure on finding efficient ways to transform hydrogen into other molecules. So the trick here is finding catalysts that work at lower temperatures, that are more selective, and are especially more stable. So at the end, it all depends on how much hydrogen we want to transform into another molecules. If the volume is small and the distances in which we want to transform to transport these molecules is also a short distance, I think we already have technologies for solutions that are local. But if we are thinking about making enormous amounts of these other molecules, I think we still need to work a lot in terms of finding materials that are really efficient to carry on these transformations. So I agree with Robert and Felipe. I think that dimethyl ether and ammonia are the particular candidates that we need to think about, because there's already infrastructure that is installed to use these molecules and to transport them. But there are still many challenges that are ahead of us that we need to work on.
Fantastic, Juan Carlos, thank you. Well, we are gonna have to switch of topic now, because there is not only challenges relative to alternative fuel oils, right, and synthetic e-fuels, but there is a strong demand on moving towards electromobility, and that's where lithium batteries play a key role on this, right? Which is it's the main conversation, the main topic conversation that we're gonna have with Juan Carlos. So Juan Carlos, there is a demand for developing new technologies that are more sustainable than the ones that are being used today. We in Chile use evaporation and carbonatation for producing high purified lithium carbonate, but now there are so many other alternatives that are being developed. Which one, in your opinion, will benefit the most to Latin America and the Caribbean? What is your opinion about these big impulse that have been received, the direct lithium extraction technologies? If you could comment on that.
Yes, well, I think that direct lithium extraction technologies are a good possibility for many reasons. These sets of technologies involve the use of membranes, the use of good adsorbent materials, the use of ion exchange, and even electrochemistry to work particularly with brines, in which we know that we have very, very low concentrations of lithium. So I think the benefits of these technologies are many. One of them, of course, is related with environmental challenges. The traditional extraction methods that, as you mentioned, are typically used require significant amounts of water, particularly when one uses evaporation ponds. And the use of these new technologies are going to help a lot to conserve this resource. Also, the idea of these technologies is that they will allow to consume less energy as compared to other methods. So I think in the future, the tendency is going to be to move towards these direct extraction techniques.
The two most important lithium producers in the world are Chile and Australia. Both apply different technologies. Australia, they actually process rocks, permagnetites, right? They do just traditional mining, and then they do leaching. While we in Chile, we process brines. I mean, high concentrate lithium in saline solutions. We start from a solution. So in that regard, in your opinion, which one would be more sustainable in the future? What would be best fit for a sustainable electromobility growth? Mm-hmm.
Yeah, that's actually a very tricky question, I think, because whether lithium comes from brines of pegmatites and what makes more sense, it depends on actually several factors, I think. So one of them has to do, again, with the environmental impact, but also with the resource availability. So at the end, it all depends, in many cases, of where your lithium is, depending on the region or in the world where you are. But also we need to think about extraction efficiency and the technology advancements and the place at which they are right now. So I think both the use of brines or pegmatites have their own advantages and challenges. So as I said, in the case of brines, some of the advantages is that if you adapt some of the newest technologies, you will have a lower carbon footprint, definitely. And of course, the scalability is important, particularly in the lithium triangle in South America with Argentina, Bolivia, and Chile, where you have vast deposits that can be exploited, which wouldn't be the case, for example, in Australia. However, the challenge with the technologies that we are using so far is how to avoid using so much water. So that's still one of the main problems. And also another problem is that these processes right now are very, very slow. In some cases, you can take up to 18 months to produce good amounts of lithium from these resources. Now, if you consider pegmatites, the advantage from pegmatites is that they contain higher concentrations of lithium than brines. So the extraction times are usually much lower than those that we have for brines. But of course, there are some challenges associated with the use of pegmatites, and particularly is that the use of the so-called hard rock mining has a very significant environmental footprint, including land disturbance, habitat destruction, and of course, higher energy consumption. So while both brines and pegmatites have the potential to be sustainable lithium sources in the future, I think the most sustainable option will likely depend on the advancements in technologies. So it depends on where the money is invested. If the money is invested in developing the technologies for pegmatites, then that will be the future. But if the money is invested on brines, the future is on brines. And that depends a lot on the governments in the particular countries.
Juan Carlos, you just mentioned the lithium triangle, let's say Argentina, Bolivia, and Chile, which are mainly brine sources. But given the high expected demand of lithium, many new resources have been identified in Latin America, including Peru, clays, in Mexico, clays as well. How do you see, what is the possibility that these resources could be developed, and what would be probably the most important social and economical challenges for see that happening?
Yes, particularly in the case of Mexico, the main challenges are particularly social right now. So that's a factor that cannot be disregarded, and we need to consider very, very seriously. One of the main concerns that people have when exploitation of some mineral is going to take place in their communities is how they are going to be affected in terms not only of their resources, but in terms of how fair the wages will be for the people who will work there. So there are, of course, many potential positive economic impacts, but we need to make sure that those impacts are clearly identified and communicated to people, and that the profit from these technologies is evenly distributed among the community, so that they can be part of this positive impact. So as the global demand of lithium increases, of course, these projects in our countries can help diversify economies that in some cases heavily depend on a few industries, especially in Latin America, such as agriculture or even traditional mining. So these projects will have a tremendous influence on job creation and employment. But we need to make sure that the jobs that are created are jobs also at the high end, in terms of having the capacity to have very good engineers and specialists on these issues. So the revenue should be invested also in social services, so that people get engaged with these projects. Social services like healthcare, like education, like housing, that improve the quality of life of the people in these small communities. And as I said, it's important to provide fair compensation and benefits to people.
Yeah, and I completely agree with you. We are in Chile just coming out of a long negotiation with the lithium industry that talks more than 5 years, until we finally came out with a new regulation that apply a royalty over the sales, which create a money fund that is used for research that will lead to innovation and development, and services and high pay jobs. So yeah, all the country, and I think this is a long discussion. We need to find out a way so these possibilities transform in positive impacts for the society and the communities around. So the role of public policies, perhaps, and the experience that we could share become key aspects of these opportunities, right? Public role, regulation, as Felipe and Robert mentioned about hydrogen, we have the same issues on lithium development. What do you think there are the opportunities there for universities and research institutes, for collaboration between Europeans and Latin American institutions to accelerate impact, to accelerate innovation, to accelerate the role of the private sector? Juan Carlos, what are your thoughts about this?
Yes, I agree. I think in general, collaborations must exist. Definitely, we cannot live isolated from each other, and particularly collaborations between institutes in Europe and Latin America can definitely accelerate innovation in the lithium industry. It can be done at different levels. The first level, of course, has to do with basic science, basic research, and I think we are seeing some of that already. But we need to go to a different level, to a level to solve specific problems in a specific sectors of the population, and of course we need to also involve the private sector directly here. There are many ways in which these collaborations can start. Of course, one of them will be from research projects, particular research projects that facilitate the mobility of researchers and students between Europe and Latin America. Conferences and panels like this, I think, are a good starting point. But we need to identify the specific problems of each region and attack those problems collaboratively. Exchange programs and fellowships can facilitate these collaborations, but we still have a lot to do in terms of, as I said, finding exactly particular aspects that need to be solved. And that's difficult to do in collaborations, because the interest might be different from both sides. So that's a thing that's always challenging in collaborations. Now, at a different level, I think that one thing that can be done is establishing what we can call innovation hubs that are focused on lithium extraction and processing technologies. I think those hubs can drive advancements and the commercialization of new technologies. So at the end of the day, industry wants to see profit from these new technologies. So we in universities or in research centers need to make sure that the technologies that we are developing at the end of the day will lead to profit. So in that sense, I think we can have partnerships between European and Latin American researchers to form these hubs that might be beneficial at the future. So collaborations between Latin American and European countries could also be supported by the private sector, but we need to convince them to put the money in there, and that's not an easy task usually. So there should be some synergistic efforts that at the end lead to sustainable growth and competitiveness of both regions.
Mm-hmm. Thank you, Juan Carlos. Well, I think we all agree that the challenges for the societies today is to provide from the technological areas answers to move the activities, economical activities, toward a more sustainable production method. So that requires a wide view from cradle to cradle, from production point to demand point, step by step what you are doing and how you can use synergy. That means perhaps to change paradigms, to change ways that we used to do things, to get together from the resource itself to the point where it's used and finally deposit, right? That plans so many challenges, so many questions that we need to address. I don't think anybody would be able to answer this alone. It requires high hubs of collaborations, as Juan Carlos said. It requires regulators, private sector participation, academy, of course. How we, and this is an open question for you, Felipe, Robert, Juan Carlos, how we could help on fostering these collaborations, on accelerate the development of the hydrogen and lithium industry in a sustainable fashion. Robert, Felipe,
Okay.
second, Juan Carlos.
I didn't know who started, sorry.
Sorry, I didn't give you the order, but this is the, yeah, please try to close your idea, because this is the last 10 minutes we have, so Robert.
Okay, from my point of view, I mean, we need research and development initiatives, like partnerships between universities and research institutions. Innovation hubs would be great on clean energy and hydrogen, as well as pilot projects to work on that together. And what's important is we need an awareness on the benefits of the renewable energy and green hydrogen. So this is also, from my point of view, a really important one. And the implementation of those initiatives that will require collaboration between the governments, between the international organizations, educational institutes, and of course also the private sector as well.
Yeah.
Thank you, Felipe.
We start, yeah. So Robert has spoken about the institutional side of things, that I completely agree on everything. I want to speak about the interpersonal and leadership side. of these collaborations, because at the end, all of these institutions are driven by people, and it will be hard work, right? It will be hard work moving towards some green hydrogen, something that now is more expensive. It's much easier to build carry on building fossil fuels. So I think this versus a mindset element within the academia and industries that you cannot keep doing the easy thing, at least in Latin America, right? I'm speaking here. And one solution for that, and I will make it personal in a positive way. So for example, Robert has always been very open. Whenever I talk, because I have met him before, whenever I talk to him saying, oh, is there like any possibility for an internship for my students, or do you want to come here and speak about a particular topic? These are like very small things, but this is not something that you see in all companies, and having the right leadership in the people that are the main drivers, saying like public institutions, big research institutes, universities too, making the self-criticism towards us. For example, we sometimes focus our research in whatever, not necessarily diseases, but it's our comfort zone, rather than, again, doing the hard job, moving a little bit, giving the step up, convincing the industry, as Juan Carlos said, which is basically selling a product. So I think leadership, like who is the dean of a school of engineering, or who is the head of a particular area, it will be really important. And also thinking on the future in our students, because I'm a lecturer. I'm telling them that they cannot keep doing the same thing in my lectures. I told them specifically, you should be going to the hard way of creating a new product of innovation of technology basis. And really there is a responsibility of us, in the universities, professors or lecturers, to give that mindset and really promote, and here come back the institutional side, create the platforms within the university or within the companies that maybe like some funding for startup projects or connecting to a bigger industry, or some funding that students can connect with the research and development area of a company, let's say, that produces now natural gas and wants to move to hydrogen. And yeah, basically, we need the right people.
Yes, I completely agree with both Robert and Felipe. I think at the end of the day, it's the people, and I will say that there are three things that we need. We need good leaders, we need good experts, and we need people who find ways to communicate ideas effectively, so that things can happen. So people who are experts in research and development, they have to find ways to communicate those ideas effectively to those who take decisions. And leaders must be open to listen to those experts and understand the positive implications of their ideas. And that's pretty easy to say, but it's really hard to do. And we definitely need to work towards that direction. I think panels like this are important. And they will be very, very effective if we include in them people who are actually in the position to take decisions. Because in that way, we can start building channels of communication with those who can actually change policies and make things happen.
Well, thank you for your thoughts, Juan Carlos, Felipe, and Robert. Yeah. Obviously, we need to communicate. We have a responsibility to inform, to communicate with the people, to came out of our isolated space of laboratory. I'm a material science engineer myself. I mean, I'm a what you could call a laboratory MASFA. So, but I think it's a responsibility to communicate until the current challenges to the people, how we see the world, how we share a view of it, how we promote changes, right? And that question are today demanded by society. They don't just want us to do teaching or do research. They want answers to their future, how we see the society, how we see the world moving on, right? And these are main topics. How we move away from a fuel oil industrial society, right? In that regard, I have one question from the public. So I will leave it open for you to answer. Considering a successful energy transition scenario, where the necessary electrification is achieved. So the question is hydrogen really a necessary source as is described today on the society, or is more just a transitional resource to be able to meet the current needs? Perhaps Robert, start from you.
Yeah, I can try to answer these questions. For me, it is we need both. That's for sure. I mean, there are a lot of applications which cannot be electrified. So we still need molecules in our energy system. That's for sure. We need, for instance, hydrogen for the heat production in the chemical industry. You need to decarbonize or to defossilize the steel production. You need hydrogen. You need hydrogen for the transport sectors. There are a lot of applications, off-road applications, shippings, aviation fuels, or the aviation sector as well. You need molecules in the energy system. So you need both, definitely. There are still some uncertainties about about the price of hydrogen and the electrification, which applications can really be electrified in a sufficient way. So we still have some points on that, but for me, we need both, definitely hydrogen and renewable electricity in the energy system.
I agree. Felipe, please, your opinion.
Well, I don't know what to add to the perfect answer, Robert, but I will add something that we need to remember is that we need to store renewable energy. We need a storage technology because we have the intermittency that we don't have with fossil fuels. And we cannot build a 1 million batteries. Yeah? I mean, we could, but personally, I think would be not the best idea. And molecules such as hydrogen and other carriers can help not only to transfer, but also to store the surplus of renewable energy production. So in that side, all development in the green hydrogen industry many times bring also benefits of decreasing the cost of energy storage, which is absolutely necessary for the energy transition regardless the scenario. The other element I would put is that building this capacity for hydrogen production, it also gives opportunities, especially for Latin America and developing countries, of creating products that have a little bit more brain behind, right? It's not just like the rock. Sorry for saying it that way, but I think it is important to see it as an opportunity of development. And as Juan Carlos said, there are local opportunities that can bring a lot of value for the development of the countries.
Yeah, I would like to add something about it. And I think it has to do with the perception that when we talk about energy transition, it sounds as if we will migrate from one system in which we are highly dependent from fossil fuels to another system in which we will be highly dependent on electricity. And I think that will be a mistake to do. Something that we've learned over the last 100 years is that the problem is that we depended highly on one single thing. So I think that in the future, we should live permanently in a transition in which multiple possibilities to have energy vectors are present. So I don't think we are going to evolve into, or we shouldn't evolve to a society in which we will depend only on one single thing.
Good point, Juan Carlos. Good point. Perhaps it wouldn't be a good idea, and it's going to take 50 to 100 years of development to see how will be the future in equilibrium, right? So still so many questions, still so many different things to be answered before we move forward. And And I think those opportunities where these opportunities where we get together, we have conversations, we share our thoughts. They are significant contributions to see and foresee that future together that needs to be built, that needs to be developed. So I would like just to do a final conclusion of this section, which is hydrogen and lithium are alternatives to leave behind 100 years of dependency of fuel oils. And as we observe in the world today, this seems to be the current alternatives that we have handy to give answer to society. Probably in 10 or 20 more years, there will be more alternatives available that we also would like to explore. But today, electromobility based on lithium-ion batteries and use of hydrogen produced from water, they seem to be the best alternative we have to provoke a change in the short and medium time. Mm-hmm. But to do that happen, to really make it happen, there are so many challenges that need to be faced, like the number of specialists we need in each one of these areas, the number of new infrastructure that we may need to build, the efficiency of this process, the whole efficiency of this process to make it economical, and how we are able also to transit from carbon regulation to a new regulation. We need to incorporate regulators on this discussion. We're going to have to educate. We're going to have to move away from our comfort areas. So the challenges are there. I really thank you, the three of you, to join me on this conversation. Appreciate it. I would like to thank to the organizers, to the European Solaris Organization, Jose Marin, who has been working and doing this happening, to all the attendees, and well, thank you all, and we keep talking about this on the future, and hope to see you soon again.